Hello, I'm Giovanni De Caro, and today I'm gonna explain you in this video something about collisions in physics. It's not a hard thing to learn, it's quite easy actually. Well, as you see here we'll consider two types of collisions in this section, the elastic collisions and inelastic collisions. But in this video we only will see the elastic collisions. In the other video I'm gonna explain the inelastic collisions. The definition: an elastic collision is a collision where total momentum and total kinetic energy are both conserved. So, as the definition says, in a collision of two balls, the total momentum, remembering that the momentum is calculated by the mass times the velocity of the object, which will be a ball, for example, and the kinetic energy is the mass of the object times the velocity to the second, all divided by 2. Simple as you look. Right. And for example, now let's see an example, then you'll see it more clear. Right. Right, example 1. Ball 1 is at rest and ball 2 is moving towards it with a speed of 2 meters per second. The mass of each ball is 0.3 kilograms. After the balls collide elastically, ball 2 comes to a stop and ball 1 moves off. What's the final velocity of the ball 1? Right, let's draw a diagram of the situation before we calculate. Right, here we have the ball 2, which is moving towards, about to collide, ball 1. As the question says, the ball 2 has a mass of 0.3 kilograms, and also the ball 1, 0.3 kilograms. The velocity of ball 2 is 2 meters per second. Velocity ball 2, 2 meters per second. And the ball 1, before the ball 2 hit it, is 0. It is at rest. Right. Let me write here before the collision. Now let me draw a diagram after the collision. After, we have the ball 2 going directly to ball 1. Sorry. After the collision, we have ball 2 that stopped and ball 1 moving in the same direction. Right, now ball 2 is at rest. Right, here we have the mass didn't change, of course. And the velocity of the ball 2 after the collision is 0 because it stopped. Let me type here V, and let's put an F. Final velocity of ball 2. In here, final velocity of ball 1, which is the information that the question asks. Right? What's the final velocity of ball 1? Right, let me put here the momentum of the ball 2 before the collision is let's consider as P2, and the momentum of the ball 1 before the collision, let's consider P1. The kinetic energy of the ball 2 before the collision, let's consider K2, and the kinetic energy of the ball 1 before the collision, let's consider K1. Right, let's do it here also. So the kinetic energy after the collision of the ball 2, let's consider K3, and the kinetic energy of the ball 1 after the collision, let's consider K4. Right. Now let's find the answer, which is that one, the final velocity of the ball 1 after the collision of the ball 2 on it. Right. I need to rush. Right. As the definition said, the momental energy and the kinetic energy are both conserved. So let's put it in an equation. Right, let's put here before, after. So the momentum before the collision, the total momentum, equals to the total momentum after the collision. As you considered here, P2, so as considered here, P2 plus P1 equals to the total before, P2 plus P1 equals to all the momentum after. That I didn't put here, but it is P3 and P4 to be more convenient of the number, and to represent the momentum after. P3 plus P4. Right. The P1 before the collision is 0 because the ball 1 didn't have a movement. If it didn't have movement, so there's no energy. So P2 plus 0 equals to, as you see here, the ball 2 after the collision has no movement, so it has no energy. Same as before, the ball before the collision. So we can put here, we can substitute the P3 for 0 more P4. Right. So P2 momentum P2 equals to momentum P4. Now, as I said here, momentum equals to mass times velocity. So mass of the ball 2 before the movement, which you consider m2, times his velocity, equals to P4, which is the mass of the ball 1, times its velocity, which is the information that you want to find. Right. The mass of ball 2 we know, which is 0.3 kilograms, times its velocity, 2 meters per second, equals to the mass of the ball 1, which we also know, 0.3 kilograms dou, times the final velocity of the ball 1. Right. Laboratory is turned to 0.6. Right. So the answer is 2 meters per second. As you see, it's the same velocity of the ball 2 at the beginning of the experiment. So we can conclude that when two balls with the same masses, considering one at rest, when they collide, the ball that was hit gets the same velocity of the ball that transferred the energy. So basically it's that, So that's it. Thank you for watching my video. Hope you liked it, because it was the first video that I made. So, and leave in comments suggestions of my video, please. And if you have any doubt, just leave in the comments too, that I will reply you. So thank you so much.